Hello. So today we're going to talk about dictionaries within Python. So dictionaries are another iterable type of data. So it's kind of similar to lists, where we can declare a list and then we can add several items to the list and then access them individually. So I could do print my list 1, and that should print bar. And as you can see, that prints bar. So it's kind of similar to lists. So that's a list, and I'm just going to leave that up here for reference for now. But let me declare our first dictionary. So I'm going to say my dictionary equals, and then the way that you can declare a dictionary instead of a list is, instead of using the square brackets, we use curly brackets. And I'm going to say brand equals Ford. Then model is Mustang, and yeah, I keep capitalizing and I need to stop, and I'll explain why. 1964. Okay, so now let's look at these two examples side by side, just so you can fully understand what we do differently when declaring dictionaries. So aside from the fact that instead of using the square bracket for a list, we're using the curly bracket, between each item within the data, so I'm saying the data because this is a list, this is a dictionary, but I'm referring to both, you see that each item is separated with a comma. So you see, I've used new lines to kind of spread this out, but at the end of each line is a comma, and that's what's actually saying that there's a different item. So within the dictionary, each item is composed of two parts. You have this first part, which is called a key, and then the second part, which is the value. So we call this a key value pair. And that's a very common term that you'll hear in software development, is key value pair. So within a list here, well, we have to use the index of an item to get the data that corresponds to that position. Instead of doing that, we can actually use the key to reference which piece of data we want. So you'll see that my autocomplete has shown us this brilliantly, where as soon as I do my dictionary and then a square bracket, so exactly the same as when we're getting an item from a list, as soon as I do a square bracket, instead of having to provide a number which corresponds to the index, I can actually just provide the key for the value that I want. So if I wanted to get Mustang, I could say my dictionary model, and then I'll print this to the console so we can see that in action. So if I do print my dictionary model, and you'll see it'll come after this example because I've left that in. Boom. So our list is running as we'd expect, so it's outputting bar. And then over here with my dictionary, I'm printing my dictionary, and then instead of passing it an integer, or for the index, I'm passing it the key for the value I want. So I'm passing it the string model. And then what Python's doing is it's saying, okay, so it's this dictionary over here, it's the key model, so we want to give it this value. So that key corresponds to that value, and it's just outputting the string Mustang. But what we can also do is we can get the year. And you'll see this is different because this is a different data type. So here this is a string, and this is an integer. In the same way that a list can contain strings and integers, so can dictionaries. But both of them can also handle more complex forms of data. So we could have parts. I'm going to make a list. I'm going to say this car has windows, and this car has tires. So a bit less specific on this example. But now let's print the list of parts. So I'm going to comment out this print statement above for the... Actually, I'm going to get rid of the list now because I think that's probably served its purpose. So I'm just going to print the parts that are within this dictionary. And if you think for a sec, think what's going to happen here? Well, we're going to go into my dictionary. We're going to pass it the key parts, which means it's going to give us the value that's assigned to that. And the value is this thing that's after the colon. So that'll be a list. And you know this is a list because it's got the square bracket. So we've got a list of items, a list of strings. So when I run this, it's printed that list of strings because this is the value that corresponds to that key. And another way to help kind of illustrate that is if I use this little collapse bar here to collapse it, all the dictionary cares about is this top level. So the brand is Ford, the model's Mustang, the year is 1964, the parts are a list, and that's it. It doesn't care what is in the list. It's a list. So we've got the windows and the tires. Let's say I wanted to see only the first item within this list. Well then, we can chain it together. So now I'm saying I want my dictionary, I want the parts, and now that means we're accessing this list, and now I want the first item from that list. So this should output Windows, and it does. So that might be a little bit confusing. I understand, but if you were to play around with this a little bit, I think it would make more sense. And let's now just see one other example, and I can't really think of a car-related way to do this, but we can nest dictionaries within dictionaries. So it's hard to come up with a specific example for when you would do this, but it's just good to know that you can. You can have dictionaries within dictionaries within dictionaries. You can infinitely, well, probably not infinitely, but you can thousands of times over, I'm sure, nest dictionaries within dictionaries. More than you'll ever need to anyway. So that's the basics of how a dictionary works. And finally, actually, I think I'm just going to change the dictionary name just to make this example, I think, fully complete and clear. It says my car. This isn't my actual car, but my car, and then we can access information about that car with this nice human readable format. So let's talk about changing items. Similarly to a list where we can use the index and then reassign it, we can do that here. So I can say my car brand equals and Audi. I think that's how you spell Audi. Now let's print my car again. So line by line, we are declaring the my car dictionary. We're assigning the key and the keys and the values. So I won't go over that. We're going to print my car parts. Well, actually, we can't do that because that key doesn't exist anymore. So I'll delete that. And then, so we've declared it, and then we're going to reassign it. So we're going to say my car brand equals Audi, and then we're going to print the whole dictionary. And as you can see, it says brand is Audi, and then model Mustang year 1964. So these two are the same because we didn't change them. But we can use the key to specifically overwrite or change that piece of data that's assigned to the key. Okay, so we'll get rid of that. Now let's say we wanted to remove an item from the dictionary. So let's say my car, and I want to get rid of the year. Well, the way we can do that is by using a method. So if you remember, methods we access by putting a dot after the variable. So we've got a few methods here to play with, and they're these purple ones. So we've got clear, copy, from keys, get items, etc. The ones that I'll talk about here are items, keys, and pop. Oh no, not items, sorry. Keys, pop, and values even. My apologies. So pop is what we use to remove specified key and return the corresponding value. If the key is not found, the default given, otherwise raise a key error. So let's pop the model from the dictionary. And when I run it, you'll now see that we are declaring the full dictionary, and then we are going to pop model, which means we're removing this from it, so basically like that, and then we're printing it. And that's why here, when it prints, all we're seeing is the brand and the year, because we are removing that key. Okay, so what were the other methods that I just mentioned there? Well, there was dot keys. I remember methods we have to put parenthesis on because it's like calling a function. And then there was dot values. So mycar.keys, mycar.values. Now when I say that this is a key value pair, so these are the keys and these are the values, you might rightly guess then that what's going to happen here is mycar.keys will print a list of these keys, and the values will do the same for this side. And that's exactly what happens. So we've got the dict keys are brand, model, year, and the values are Ford, Mustang, and 1964. You'll notice that they get wrapped in this, in these like function-esque names. This is a thing that's specific with dictionaries. It's just the way it returns the data. What I would recommend doing is you can convert that directly into a list, so then it's in a format that we've used before. So if I take the value of this and I convert it to a list by using the list function, you'll see now that it looks much more familiar. So the brand, model, year, Ford, Mustang, 1964. So the final thing to go over with dictionaries is you can actually loop over them similarly to lists, because they are an iterable type of data. We can iterate over them. So to do that, I'll illustrate it with a for loop. So I'm going to say for x in mycar, and I'm going to print x. So what this will do is it's going to go over line by line, and it's going to print the value that it gets. So when I run this, you'll see that we get brand, model, and year. So what's actually happening is we're only seeing the keys, which might look a little bit odd, but it makes a lot of sense. The reason that we only get the keys is because using the key, we can then get the value if we want to. So what I mean by that is, here we can print the key. If I wanted to then, on each iteration of the loop, get the value instead, it's as simple as using the name of the dictionary and passing the key to it like that. So mycar, square brackets, and then x, because bear in mind x here, which I'm printing, in each iteration it's brand, then it's model, then it's year. That's the equivalent of doing print mycar, brand, model, and then year, because x on each loop will equal one of the keys. So what I'll do is I will print it, but I'm going to first, on each loop, I'm going to print the key, and then I'm going to print the value by passing the key to the dictionary. So let's run that, and you'll see, so it's going brand Ford, model Mustang, year 1964. We can make this even more readable by perhaps using an F string. So we'll go X. Okay, so we have talked about these, but an F string is how we can add data within a string to print it. So we're declaring our string here, and then the first thing we're doing is we're printing X, and then we're going to print the value which is returned when passing the key X to the dictionary. And you'll see, isn't that much nicer? Brand Ford, model Mustang, year 1964. So the one last thing I want to mention is that in the beginning, when I was declaring the dictionary, I was saying that I need to stop capitalizing my keys. And the reason for that is that keys are case sensitive. So I'm going to remove that now, and I'm going to print mycar brand with a capital B. And if I run this, I get an error, key error. So if you ever want to do any try catch logic, you would use a key error if the key didn't exist. But you can see the key brand doesn't exist because it doesn't. This is uppercase. This means it's a different string. This is not equal to this. So this would have to be lowercase. So one good way to enforce this. So if you do ever are using, say, an input to get input from a user, and you want to make sure that the capitalization doesn't break anything, by converting it to lowercase, you can make sure the key will always exist if it's actually typed correctly. So here I'm declaring a key as uppercase B for brand, and then when I'm passing it to the dictionary, I'm converting it all into lowercase to make sure that it equals that key, and that means that it now works. Okay, and there was one last thing which has just occurred to me as well, which I do want to show you real quick, is that dictionaries have to have unique keys. So if I go and add this, what do you think is going to happen? Well, you might have one of two guesses. One will be it might throw an error because I've told you can't have duplicate keys. But let's see what actually happens. So when we printed it, we've got the brand equals Ford, the model equals Mustang, so that's all correct. But then the year is 1965. So the reason for that is, as we've talked about a few times, Python is sequential. It goes in a sequence. It goes from top to bottom. So as this dictionary is being declared, it's going right. The brand is Ford, the model is Mustang, the year is 1964. Okay, now the year is 1965, and it's just overriding the previous data. And that's why if you have duplicate keys like this, you will overwrite the previous entry. So you do want your keys to be unique. And I think that's pretty much everything I want to go over as an introduction to dictionaries. But what I would encourage you to think about is ways that you can use dictionaries instead of lists to house data that is more easily referenced or referable. Because if I wanted to store all of this data about a car without any type of iterables, I could go my car brand, equals blah blah blah, and then I could have another one called my car model equals this. But then I've got loads of variable names. So without dictionaries, if we're using lists, we then might have a list called my car and then just have Ford and Mustang, etc. But then we don't know what these actually are, and if we want to refer to them, we're having to use these arbitrary index numbers, and the data could move around. And that's where the power and flexibility of dictionaries is super valuable, because we have these understandable, very clear ways to reference data that all belongs to a shared kind of item. So in this example, the car. Okay, thank you.